Okay, so we are going to be talking about 4.7 solar radiation and Earth's seasons. And I'm going to stop my webcam for a second and go over a really important term for this section, which is insolation. Insolation is the amount of solar radiation that reaches an area, and it's usually, or it's always measured, usually, I guess I should say, in watts per meter squared. And so the solar radiation is the energy from the sun's rays. So all of the energy that reaches the Earth's surface in an area, that is the amount, that is what insolation is. Okay. All right. So let's go ahead and get started. So the first thing that you need to know about is solar intensity and how it impacts latitude on the Earth. So solar intensity of insolation, that intensity of the sun, rays depends on the angle, how directly the rays strike Earth's surface, and the amount of atmosphere that the sun's rays pass through. Okay, so if there's more atmosphere and it's at a higher latitude, it'll actually be, there'll be less sun's rays, the intensity will be less. More sun's rays at the equator because there's less atmosphere to pass through. It's not passing through all of this, it's just going directly right here. And the latitude is at 0. And so that's going to be more intense. Okay, so the higher insolation at the equator, so at the lower latitudes, we move to the upper latitudes, there's going to be uh, lower insolation. Okay. All right, so here's just another example of this. Look at all of the Earth's atmosphere that this is passing through. So that's going to diffuse some of that sunlight and make it less intense. Again, more atmosphere, less intense. Less atmosphere, much more intense. Okay. It's also a much smaller surface area, whereas this is a larger surface area that it's covering. Okay, so you can see here, if we were to calculate the solar insolation, this would be at 400, this would be at 200. All right, and so solar intensity and season. So the orbit of the Earth around the sun and the tilt on the axis changes the angle of sun's rays. So this causes varying insolation. It varies throughout the length of the day and with the seasons. Okay, so you can see basically what that means. Is that the insolation of the sun here in June, at the June solstice, the summer solstice, the Tropic of Cancer is going to be getting more sunlight than any other area of the sun. The sun's intensity would be greater at the Tropic of Cancer, which is further north than the equator. So the equator is actually going to be getting a little bit less. This is when the northern hemisphere is in summer. The southern hemisphere is going to have a much lower angle of insolation, so less intense sun. They're going through winter. Okay, so like I think of Australia, South America, they'll be in winter here in June while we're in our summer. And then this is just directly opposite of that. So here's the December solstice. And you'll see that the Tropic of Capricorn, which is the negative 30 degrees latitude, is going to be getting the more direct sunlight. So in December, that's when the southern hemisphere is having their summer and we're having our winter. Okay. Here in the March equinox and the September equinox, the sun's rays are directly hitting the equator. So this would be just, like our spring and our fall. So it's not really summer, not really winter. We're just kind of getting our kind of average amount of solar radiation. Okay, and the tilt of the Earth's axis causes variation in that angle of insolation. And it also causes the length of day to be different, and then also obviously causes seasons. So I'm not going to read all of that to you here. I think this is probably something that you've learned in the past. But this might be a good place to pause the video and just kind of review that for yourselves. This isn't a huge topic on the AP test, but it is important to understand that angle of insolation. That's key. The length of days and the seasons and how much sunlight we're getting and all of that isn't quite as important of a topic. So it's really that angle of insolation. So if you'd like to pause here, you can do that, but I'm going to move on. Okay, so albedo effect. Albedo is proportion of light that's reflected by a surface. So surfaces with higher albedo reflect more light and they absorb less sunlight. So I think a good example of this is like the sun. The sun has a higher albedo than water. And so, I'm sorry, I said that incorrectly. Ice, snow and ice, has a higher albedo than water. And so they're going to reflect more light. That snow and ice will reflect more. So they're absorbing less. So they tend to not melt and they don't warm up as much as, say, water. Water, when it is hit with that sunlight, will actually absorb more. And so the reflection is much, much less. And so the energy from the sun, then, that sun's energy will actually cause the water to warm up. Okay, so low albedo reflect less light and absorb more heat. Okay, so albedo and surface temperature. So surface temperature is affected by albedo. When sunlight's absorbed by a surface, it gives off that infrared radiation from the sun. It's not actually heat that's coming from the sun. It's infrared radiation that objects on the Earth's surface absorb and then heat up or reflect. Okay, so they absorb that UV radiation and either heat up, or that infrared radiation, and they heat up or they release it. Okay, and so urban areas um, basically have a very low albedo. And so concrete, blacktop, they have a very low albedo. So just like water, they're absorbing a lot of that UV radiation, which is then transforming into infrared or heat. And so they heat up a lot more, which causes something called the urban heat island effect, where in cities that have a lot of low albedo surfaces will actually absorb a lot of that heat, and it causes the temperature within the cities to be much warmer than areas surrounding. So much warmer than suburbs or rural areas or whatever. So polar regions are a lot colder because they actually have a very high albedo. And so understanding that the albedo effect, or the albedo of an of a of an object, actually causes like these temperature differences. That's important to know. Okay, so here's our practice FRQ. Identify which season is taking place in the northern hemisphere in this diagram. So I'll kind of stop my webcam. Describe how the tilt of the Earth's axis is responsible for for the Earth's seasons. So that just kind of reviews what we talked about in the notes. If you have any questions, you can let me know in class or see me during Pathways, don't forget. And then I will have the answers for this FRQ up on OneNote, so you'll be able to see that. Okay, I'll see you guys next time. Next time we're going to be talking about Earth's geography and climate. See you later.